Hello, good day. We're going to work on Math 133, Chapter 6.2. It's over binomial probability distribution. And let's go ahead and share my screen here. Right here. And we're looking at a criteria for a binomial probability experiment. So binomial has a prefix of 2, which means binomial is bi, which is a prefix for 2. So there's 2 outcomes. And it says an experiment is said to be a binomial experiment if the random variable performed a fixed number of times. So that's what we're looking for, the fixed number of times. And each repetition of the experiment is called a trial. The trials have to be independent of one another. And then there has to be 2 disjoint outcomes. So only 2 outcomes. One will be a success, one will be considered a failure. And the number of successes is going to be between 0 and n. The probability of success is consistent for each trial of the experiment. And then P is the probability of success and Q is the complement, or 1 minus P. N, P, and Q should be given in numbers, and S, F, and X will be given in words. So let's go ahead and look at examples. So example 1 says, a student takes a multiple choice test that has 10 questions. Each question has 5 choices, only one of which is correct. The student guesses randomly at each answer. Explain how this experiment is binomial and identify N, P, Q, S, F, and X. So 1 is the fixed number of trials is 10 because there's 10 questions that they're randomly choosing an answer to. And 2 is, yes, each question is independent of one another when they are guessing. And 3 are the 2 outcomes, success and failure. So success is correct guess, and failure is an incorrect guess. And 4 is the probability of success. P is equal to 1/5. And Q is the probability of failure, which is 1 minus P, which is equal to 4/5. And so we have N, we have S and F, we have P and Q, and then X is between 0, greater than or equal to 0, there it is, and less than or equal to n, which is 10. So X can be, the number of successes can be anywhere between 0 and 10. So example 2 says, determine which of the following probability experiments qualify as a binomial experiment. For those that are binomial experiments, identify the parameters, and if it does not, explain why not. So it says we have a loaded die that has all 6 numbers, but is weighted in such a way that it tosses a number of 2s 75% of the time. So this weighted thing, no, because the probabilities aren't independent. So because it is weighted, it's going to be a no right there. And then it says we toss the die and record the number of rolls it takes to obtain a 2. Ooh, so we also have an issue of not a fixed number of trials. Because it says we're going to keep rolling until we get a 2. So I could roll and get a 2 on my first roll, but you might have to roll 5 times before you get a 2. So not a fixed number of trials. There's a couple of issues with that one. B says, according to a 2017 biomedical research paper, 81% of people who have coronary bypass surgery are over age 60. 20 random coronary bypass patients are sampled and the number who are over 60 is recorded. So do we have a set number of trials? And that would be yes, N is 20. We gather data on 20 people. And the patients should be independent of one another. Patients are independent of one another. And then we have the success is they are 60 plus in years. Failure is they are less than 60 years old. And the probability of success is 0.81. And so Q, the probability of failure is 0.19. And X is anywhere between 0 and N, which is 20. So that one is good. Let's look at C. C says a jar contains 5 red marbles, 9 blue marbles, and 6 green marbles. You randomly select 3 marbles from the jar without replacement. The random variable represents the number of red marbles chosen. Okay. So do we have a fixed number of, we do. So N is 3, we're choosing 3 marbles. And are they independent? So not independent, this is our glitch. They're not independent because we're not replacing them in the jar. So if we remove one, it changes the number left in the jars, which changes the probability of the next marble being drawn. So not good. Okay. So let's look at the next page here. So the next page says, if we have a binomial probability function, to find the probability for different binomial problems, use the following. N is the number of fixed trials, P is the probability of success, A and B are the number of successes in a specific problem. Okay, so sometimes we're given situations in words, sometimes we're giving it with symbols, and then this is what we're going to be using in the TI-84. But also we are going to be using StatCrunch, which is amazing as well. So, and I'm going to show you in StatCrunch. Down here, the StatCrunch just instructions, and I'm going to show you today how to use that. So we have exactly equals, is, none, all, or given is going to be an equal sign. Less than or fewer than is going to be the less than symbol. Less than or equal to, that includes the equals. Greater than or more than is a strictly greater than or equal to, at least, not less than is including the equals. And then a between inclusive is this situation. So we're going to look at a few situations here and see what we come up with. So it says, determine the indicated probability for a binomial experiment with a given number of trials and a given probability of success. So N is equal to 15 and the probability of success is a quarter. So P is equal to 0.25. And we want to know the probability that X equals 2. So when a number is there, we're assuming it's the X equals. So we're going to go and share our screen to that's to StatCrunch here. And we are going to go to Stat, and this is on your page in your notes. It says Stat and then calculators, and we're choosing binomial. And then we have to enter down at the bottom the N. So our N in this case is 15, and the probability of success is 0.25. And then we can change this inequality. So we want the probability that X is equal to 2. And then we're going to hit enter. And so that probability, the probability of 2 is equal to 0.156. We'll round to, it says 4 decimal places. So 0.1559. Let's read B together and then we'll do it on the screen. So B says N equals to 85. I'm going to change that. P is 0.03 and X is less than, so it's a strictly less than, and 4. And compute. And that is equal to 0.7483. And I'm going to take you back to my paper in a moment so you can check all the answers. So this one that we have on the screen right now is for letter B. So let's go to letter C. It says n is equal to 16. We'll change that. And then P is 0.78. And it says probability that X is greater than or equal to 11. And we'll hit compute. So n is equal to 16. And it says that that probability is equal to 0.8812 when we round it appropriately. So what's on the screen is part C. Part D says n equals 8. So if we're choosing 8 random questions, let's say, and the likelihood of randomly choosing the correct answer is 28%. And we want to get, it says it probably that the number of correct answers guessed is between 2. So this is where we have to go up here. See where it says we were in the standard. Anytime we go to in between, it kind of just, it's just one little situation that's in between. And so we're doing in between of 2 and 5. Anywhere in between 2 and 5. And that likelihood is 0.6953 rounded appropriately. So I'm going to share my screen so you can see what I came up with. These were our answers for A, B, C, and D. So A, B, and C were all standard in StatCrunch. This one is a between option. Now we have example 4 is all about describing some situations in words. It says a student takes a multiple choice test that has 10 questions. Each question has 5 choices, only one of which is correct. The student guesses randomly at each answer. So we have to know N. N is the 10 multiple choice questions, and we have to know P, which they said there's 5 answers and 1 is correct. So probability of success is 1/5. And this says describe P of 4. So this right here is the probability that the student guesses exactly 4 questions correct. So we're going to go back to StatCrunch. And we had 10 questions. And it was 0.2, 1/5. And oh, we got to go back to standard. And it was exactly, so we're going to do an equal sign. And he got exactly 4 of them correct. And that comes out to be 0.0881. B says the probability that X is less than 6 in words. So this is the probability that they guessed, and it's a strictly less than, so guessed less than or fewer than 6 questions correct. So strictly less than 6 means that they had 5 or less, so 0 through 5. So let's 10 and 0.2 are still the same. This has to be strictly less than, and then we're going to put in 6 and compute, and we'll go back to our paper. So this is 0.9936. So this is 0.9936. The probability that they guess less than 6 questions correct, or you could say fewer than. The next one says the probability that they guessed more than 2 questions correct. Not at least or 2 or more. They has to be more than 2 because this is strictly greater than. So let's go ahead and check that out here and StatCrunch. So that is a more than, so we're going to go to more than 2. And that is 0.3222. Okay. Letter D says, this is an in-between. So we have to check in between here in our StatCrunch. It says, find the probability that X is greater than or equal to 3 and less than or equal to 8. So in words, it means the probability they guessed at least 3 and I'm going to say less than 9 because that's the same as, or we could say at least 3, and then we'll write, I'm going to go back to my paper so you can all see what I'm doing here. So I said the probability that they guessed at least 3, at least is it greater than or equal to, but no more than 8. So that means we include 8, no more than 8 correct. So let's do that. So this is 3, and this is 8. And that probability is 0.3222. Okay. So it says, to pass the test, the student, let's look at E. E says, to pass the test, the student must answer 70% or more correctly. 70% or more. 70% or more of the 10 questions means that they need at least 7 correct. Would it be unusual for the student to pass? So the probability that X is greater than or equal to 7, that's what we need to find. And then we have to answer that, would it be unusual thing? Let's see what, so greater than or equal to 7 is pretty small, 0.0009, which is less than 0.05. So yes, it's definitely unusual. So let's go back to our paper and mark that. Yes, it would be unusual because it's less than 5%, which is 0.05. Yes, it would be unusual. And the explaining, as long as you show me that it's less than 0.05 or 5%, then that satisfies the explain. Awesome, we got some practice translating symbols to words. Okay. So, example 5 says, according to a 2017 biomedical research paper, 81% of people who have coronary bypass surgery are over age 60. So this is one of the problems that we brought up earlier. 20 random coronary bypass patients are sampled and the number who are over 60 is recorded. Find the following. Okay. So it says N equals, so N equals 20. And P is the probability that they are over age 60. And that is 0.81. And then it says that probably that fewer than 15 of them are over age 60. So let's write out our symbol here. So the probability that fewer, not including 15, so it's just going to be a strictly less than 15. Okay. Let's fill in all of these symbolically and then we'll go to StatCrunch. It might be easier. The next one says that probably that more than 13 of them are over age 60. So more than 13, but I don't think we're including in 13. So probably the X is greater than 13. Then D is the probability that at most 13. So X is less than or equal to 13. So at most. E says the probability that at least 18. So the X is greater than or equal to 18. And then F is the probability that between 12 and 15. So the probability that between 12 and 15. And then G says, suppose all of them are over age 60. Would this be unusual? So all of them would be X equal to 20. Okay, so let's go to StatCrunch, and we're going to start with B here. X is less than 15. So we have to adjust our N, and our probability is 0.81. And our first one is X is less than 15. And so that is likely. Fewer than 15 is 0.1643. Then it says greater than 13. So greater than 13 is equal to 0.9311. Letter D says, we said it was less than or equal to 13. Compute. And that is equal to 0.0689. And then E is greater than or equal to 18. And that is 0.2386. And F is a between, so we have to go up, up to our between. And we said between 12 and 15. And that is equal to 0.3200. And then G was, suppose all of them are over age 60. And what would that look like? And so that one would be back to the standard and an equal, all 20. Compute, and that's pretty small, 0.0148. Let's take you back to our paper so you can check all the answers that I wrote down. So B is 0.1643, C is 0.9311, D is 0.0689, E is 0.2386, F is 0.3200, and G, the likelihood that they're all over 60, all 20 patients, is 0.0148, and it's less than 0.05. So yes, this would be unusual. Yes. Okay. So now with the binomial experiment, we also have like, what is the average and the standard deviation on a binomial experiment? So we have a formula here that the mean of a binomial experiment is simply by taking N times P. And the standard deviation of a binomial experiment is the square root of N times P times Q. So let's put this into practice. It says a student takes a multiple choice test. It has 10 questions. Each question has 5 choices, only one of which is correct. So we've kind of looked at this scenario. The student guesses randomly at each answer. Here's a histogram of the probability distribution from this experiment. Here is our histogram. Compute the mean of the distribution. So we're going to take the mean is N times P. So N times P. And N is 10 and P is 0.2. So that comes out to be 2. 2 is right here where the mean is. Label it on the graph. Compute the standard deviation. So this is going to be the square root of NPQ, which is the square root of 10 times 0.2 times Q, which is 1 minus P, so 0.8. And when we multiply those, we get 1.26. And then it says interpret in the context of the situation. So we go back to our format that we learned way back in chapter 3. So if a student guesses, worded just a little bit different. If a student guesses on 10 questions, they can expect to get 2 correct, give or take 1.2 questions. What is the shape of the distribution? I'd say it's slightly skewed right. And it says, explain why it makes sense. Well, it's unlikely that students are going to guess a lot of questions correct. Unlikely for a student to guess many questions correct. And the probability of 7 is the probability of 7 questions correct 0 as it appears on the graph. So it appears that it's 0 here, but it's no. It is just extremely small, so we don't see it, right? So we don't see it. That's all. That's all. So we've learned about how to find probabilities of binomial experiment. We found out how to decide if it's a legit binomial experiment. And then we also found out how to find the mean and the standard deviation of a binomial random variable. So let's look here at our last question here. It gives us 3 histograms, and it says, for each of the following graphs, when n equals 100, for which graph does p equal 0.3, probability equal 0.5, and probability of success equal 0.7? So if we look here where our center is, that center looks about 7. This center here looks maybe around 10. This center here looks maybe around 5. So let's look here. So if p equals 0.3, then the mean is equal. Remember, if we just learned the mean is equal to n times p. So this would be 100 times 0.3, which would be equal to 30. Oh, this is, I forgot. This is supposed to be n equals 15. That was a mix-up in your course pack. So sorry about that. So if n equals 15 and your probability of success is 0.3, then it's going to be a 4.5, which would be down here, this bottom one. So this one is the p equal to 0.30. And if your probability of success is 0.5, then your mean is going to be 15 times 0.5 or 7.5, which would be this one right here. And then if your probability of success is 0.7, then your mean is going to be 15 times 0.7, which is going to be 10.5, which is going to be right here. So yes, make sure that you change that to n equals 15. That was a mix-up in the course pack. And that wraps up chapter 6. There's only 2 sections to chapter 6. So We did some expected value in chapter 6, and we did binomial experiments. Binomial meaning that there's only two outcomes, either a success or failure. And sometimes you're going to have to relook at the problem and see if you can kind of group the possible answers into one success and the rest failure kind of a thing, and decide if it is a true binomial experiment. And then you can use StatCrunch to help you find those probabilities. And I'll look forward to seeing you back for chapter 7.